Hey guys, welcome back to the last section of Level 2. In this section we'll be learning about how to build a generalized speed class that will average the times that your code takes to run. So in our last section we looked at a quick and dirty way of finding how long your code actually takes to run inside the console using console.time. In this section we will actually be averaging multiple times together to get a really accurate assessment of how your code is performing. Now to get accurate average measurements for your code, we're going to need to be able to retrieve and use actual numerical time data. This is data that we can actually manipulate, right? So first thing we're going to do here is examine the JavaScript date object, which will provide us with that numerical data. If we establish a variable here called RightNow, and we set it equal to a new date object, you can see that if we logged out that RightNow variable, we get a whole bunch of date information back. You can see it was Monday, April 10th, 2014 when we called this console.log. Gives you a time value as well as a time zone. Now the new date object is immediately going to capture the current date and time, and that's going to be measured in milliseconds since 12 o'clock a.m. on January 1st, 1970. Apparently that's when they thought computers should use time. 1970, that's when time began for computers. Now a cool thing about numerical date data is that if we put a unary plus operator in front of our date object variable, it's going to ask it for the specific value in milliseconds. That means that this line of console.log is the same exact thing as declaring a new number object on the date variable. And now when we get that logged out, we see that we get something like 1 trillion milliseconds. So you know, there's a few of those in there. Now, since we know we already want an actual number and not all of that interesting date data, we can go ahead and assign the variable to be the numerical version of our new date object just by moving that plus over to be in front of the call to new date. So moving forward, we can even declare an end time, a new time, on a new date object using that same plus new date syntax. We're going to get a millisecond value for that particular time, and now you can probably see what's coming and how we're going to use this. We'll declare a new variable called elapsed time, and we set it equal to end time minus RightNow. And what does that give us? That gives us the amount of time that elapsed between when we first declared our first date object and our final date object. Cool, so now we know how to generate date objects that will hand us data that we can manipulate for time, and that will let us see how much time has passed between two events in code. So now with that, we can begin to create our very first speed test class. Let's take a look at that. So the first thing we'll do is we'll establish a speed test constructor function. And inside the parameters of that function, we will have three parameters: test implement, and that will be the specific code that we want to test for performance speed. We're going to encapsulate it in its own function later on and pass it in as an expression. The second parameter is called test params, and that's going to represent whatever parameters our test code actually needs in order to work correctly. This might be an array of values, or it might be a single value that test implement will need in order to work. Finally, the last parameter is the amount of repetitions, because why? The higher the repetitions that we use, the more reliable our average is actually going to be. So now let's flesh out what each individual speed test object will actually look like. Here you can see we've got test implement going in a test implement property of a new object. Same thing for test params. But then here in our repetitions property of our speed test object, we're going to allow the repetitions to be optional, and we're going to use our logical assignment best practice to do that. You can see that if the speed test constructor gets past some repetitions, we're going to go ahead and take those repetitions and assign it to the property. However, if whatever user is using the speed test doesn't pass in any repetitions, we're going to go ahead and just default that to be 10,000 total repetitions so that we can get a good reliable estimate. And finally, we'll set up an average property and assign it to 0 at first before we have calculated it. Alright, so that's our speed test constructor function. What we're going to do is size that down, scoot it over here, and now we need a method inside of our speed test object, but we're not going to add that to the constructor function, right? Because we want every single speed test object to have this method or access to it. So we are going to give that to the speed test prototype. We're going to use our best practice of adding very commonly used methods to the prototype. So here we go, building the speed test prototype. You can see on the inside here, we've got an inherited method called start test, and we're going to use that to begin to start the process of calculating an average speed for some sort of test implementation. First thing we're going to do inside our start test inherited method is establish these variables. The first two will be our actual numerical date objects. They will start our clock and stop our clock. Notice also that we have declared those variables using a comma separation instead of using multiple var keyword lookups. Yeah, that's our best practice. That last variable sometimes is going to be the variable that sums up all of the times for all of the repetitions that we do. Next, we'll loop over the full amount of requested repetitions. Notice that we have used our best practice of no repetitive property access at depth. We have cached that value and we'll use that value in our loop parameters. Here's where we actually use our begin time variable. Notice what we do. We establish a new date object, but we want the numerical version of it so we can do math on that numerical data. So we put that plus unary operator in the front of our new date object. Next, this is where we run the actual code for this particular repetition inside of the loop. Notice that we pass the test params into the test implement function. Then, of course, we need another numerical date object in order to stop the clock. Finally, we'll do end time minus begin time, which will, of course, give us the differential in terms of time. It will tell us the elapsed time, and we'll add that in to the sum of all times for all repetitions. And, of course, taking the average is just going to be the sum of all the times divided by the amount of repetitions that we used. Finally, we'll return a message that says the average execution across however many repetitions we used was this amount of time. Cool, so let's test an implementation using our new speed test class. The first thing we're going to do, though, is we're going to build some code that lacks some best practices and then test that speed. Let's see what happens. We'll scoot our prototype down over here underneath our constructor, and then we'll give ourselves some data to start off with. You can see we got our variable first regiment noobs. That's an array list of 4 guys that are new to the 1st Regiment and need to be added to the list of 1st Regiment Knights. You can see there the next variable is the 1st Regiment Knights list, which has tons of knight objects inside it. Now here comes the code we want to test. We want to loop over all of the existing newbies, right? And notice no best practice here. We're just going to use that repetitive access at depth that kind of sucks. We're going to do that and see what happens. Additionally, inside the loop, we're going to establish a new variable every single time, and that's going to be a new knight object, right? Using the name inside the noob list and whichever regiment he needs to be assigned to, which of course each time here is the 1st Regiment. Following that, once we've got a new knight inside our new guy object, we're going to push that to the 1st Regiment Knights list. That's our simple method for adding all of the new guys as brand new knight objects to the knight list. Now in order to test this block, we've got to be able to pass all of it, the whole block, into the speed test constructor as its own function, right? We're going to create an entirely new speed test object from the constructor and make that a new object in no BP test. But we need our code to be its own function expression so that we can pass it in to the speed test constructor. So we'll scoot our for loop down here. We will make a new variable called no BP and wrap it in an anonymous function, its own little module here. And we're going to assign that function expression to a variable. Now, once that code is inside that anonymous function, we can very easily pass it around to whatever other function we would like to pass it to. So you can see inside of the speed test call, we've now got no BP as the implementation that we want to test for speed. Now, since our speed test constructor lumps all of our test code's important parameters into one test params property, we need to modify our function in order to be able to use just one array of important stuff. So we've got here inside of our anonymous function a parameter called the list of params, just one parameter array. So we'll scoot our stuff down here and we will make that parameter array become the lists for the tests, right? Lists for test variable. And inside that array, we've got both of the arrays that our testable code will need in order to operate. Now that list, that array of arrays, is going to be passed into our speed test constructor to be all of the parameters we need for our testable function. But we now need to modify all of our internal variable names in our function to match that parameter name we created that's just one array. So let's check that out. Well, first regiment noobs, right, is the first index of our parameter array. So that's going to become list of params on the 0th index for both of the times that we access the first regiment noobs data. Scoot that over, and now, of course, the first index of our new single parameter array is going to be the first regiment knights array. And we'll scoot that over. Bring our speed test up here, and we're ready to roll. Let's see what happens when we test the speed of our prepared, albeit terrible, code sample. Oh, and one thing to note here, in creating our speed test object, we opt to not pass in any repetitions amount. So therefore, in our logical assignment in the construction, we're going to actually get 10,000 from our logical assignment operator. Cool, so we'll have to start the test by calling the start test method on our new speed test object. We get average execution across 10,000 repetitions is 0.0041. Not terrible, but we can do better. Notice, however, that we have about 10 times the speed improvement already over the estimations from console.time. A little bit of an indicator about how much time it really takes to establish a console.time timer. Now what happens if we actually want to specify how many repetitions we're going to use? We want to be a little bit more accurate, so we're going to pass in 100,000 repetitions. We get the average execution is now 0.00478, and our newer estimate actually brings us ever closer to the truth. We can rely a little bit more on that estimate. Cool, now here's where the money is. Let's go back and refactor our code a little bit and put some best practices in there and see how much our speed improves. First thing we'll do is we'll cache that loop control variable. So we'll scoot our I++ over here. And now we're going to establish that new x variable where we cache the length of the noobs array, which happens to be in list of params 0. We'll loop over that new variable. Next thing we're going to do is get rid of that internal variable declaration. Not only are we not going to declare that variable, we're going to get rid of the interim storage entirely. We're just going to create the new knight object and instantly push that into our new knights array. Magical and efficient. Now we probably need to change the names of our test function and our speed test object because it no longer has no best practices, now it has some best practices. So we'll call it BP and BP test. And now when we actually call our start test on our BP test object on 100,000 repetitions, we get 0.00274, which is a significantly better execution, especially if this process were replicated a few gazillion times up in a program. Now the important thing about a simple class like this is it's very reusable for any particular code that you want to test, so long as you group the parameters for your testable code into an organized list so that it can be passed into the function that you put your testable code inside. And that is the end of our performance level. We're going to give you a few challenges to test your knowledge with your new speed test class, and we'll see you back in the next level. See you soon. Processed. Okay, I must not suck this time. Suck less. Some people, winter's coming. Suck is coming.